we talked about how to extract characteristics of a sinusoidal. If I just give you an equation, you should be able to tell me right away what's the highest it will ever get, what's the lowest it will ever get, and the middle, right? You should be able to tell me that, as well as the length of the period, right? Like what in units. It could be time, it could be distance, we don't know. It depends on the question. And so on page 18, I talked about a wheel, because a wheel is going to be very popular, but it's not just wheels. It's going to be, I'm going to give you some examples already so you can wrap your head so you're not surprised when you get to the exam. Sometimes they do a spring. When you pull a spring and you release it, and it'll do this, right? So it'll be like, oh, that's a sinusoidal function. Over time, if you measure the distance from that object to the table, it's a sinusoidal wave. The depth of the tide, the amount of daylight in a day, it varies sinusoidally. The temperatures vary sinusoidally. The average temperature per month, okay, is usually sinusoidal. The one I've seen is also a child swinging. And so if you swing and you measure your distance to something else, to a wall or to a tree, that distance would also vary sinusoidally, right, if you were to graph that. Okay, so this is where it gets very important for you to understand. We're going to focus on, in terms of the y, we're going to focus on the high, the mid, and the low, okay? Those are the three that we're going to focus on along the y. When it comes to the x variable, we're going to always take the entire period and split it into quarters. Because what we know is that the amount of time it takes to go from the highest to the mid is a quarter of a period. And to go from there to the lowest is another quarter of a period. You see what I'm saying? So it's like a quarter turn, quarter turn, quarter turn. So that is important to remember. So let's dive into our word problems here. So this is where I just give you an equation and you just have to answer a bunch of questions. This is, I would say, one of the classic scenarios, okay? Tom goes on a Ferris wheel at the Red River X when the ride begins. His position can be modeled by this function, where h represents the height above the ground in feet and t is the time in minutes. The ride goes on for 5 revolutions. That's interesting, right? I think I got rid of that. No, I didn't. Okay, I asked the province, you're never going to encounter this, but I decided to put it in my notes just in case. Do you see the 0.5 between sign and the brackets? It's not going to happen, okay? So can we just rewrite it? Basically, if this were to happen to you ever, you would just multiply the 0.5, you would distribute it into that bracket, and that's how you get rid of it. But you're not going to worry about it, so just rewrite this with me. Just imagine this is the equation that I meant to have on there. Sine of 1.57075 t minus 0.08. I have to change that. I got it. I just noticed a slight mistake there. This would be 1.25 minus 1.25. Plus 25. Okay, so let's type that into our calculator, shall we? Type that in and try to make it appear. So rowdy. How many waves do I usually want you to see? Do you remember? I want you to see, yeah, 3 caps. 3 caps or 3 valleys at the very least, okay? So let's type that in and make that window happen. Make sure your calculator is set to radians. There it is. I'm going to graph it. Uh-oh. It looks pretty, but I don't know what did I do there. How would I fix that? You need to figure out the period. You need to figure out how long does it take for one revolution. So we're going to go period is 2 pi divided by b, which is 2 pi divided by this one right here, 1.57075. So let's see, I'm going to take my calculator here. 2 pi divided by 1.57075. So the period is for what in this case? What is my x variable associated with? It's time, right? And what is time measured in? Minutes. You see it? Time in minutes. It says it right here. T is time in minutes. So we know that it takes 4 minutes to do a full revolution. So we're going to go to window. Watch this. I'm going to go to my window. And I'm going to set x max to 3 times whatever the period is. That usually works pretty well, which is 12. And my x min is way too, like I don't need to see negative 10. So I'm just going to change my x min to negative 1. Let's try that again. Right? So when you don't freak out when you see the full screen. It's just that you're seeing too many, right? You're looking at way too many waves, and so it's overwhelming. So you just want to like zoom in. And I see 1, 2, 3. That's pretty good. Just remember from cap to cap, that is the length of a period. So if you measure it along the x-axis, it would be 4 minutes. Same from low to low, it would be 4 minutes. Okay. Okay. So this is a pretty good graph. You know what? The min and the max I could have figured out by looking at this graph. Okay. So I would actually like you to do that. Max is 25 plus 20, which is 45. The min is D. Remember, D is like your midline, right? It's the middle. So in this case, we go minus 20, minus whatever the amplitude is to get our low, which is 5. So this Ferris wheel gets as low as 5 feet above ground and as high as 45. Okay? So that should have helped you with your window as well. Like your Y max, I would have set it to 50, and my Y min, I would have set it to like minus 5 maybe, right? So you're making sure you can see this, right? So there's a lot of things that you can deduct from a sinusoidal function. Determine the diameter of the Ferris wheel. If you remember, the diameter, when you're talking about a sinusoidal function, is 2 times A. So it's 2 times 20. It is 40 feet. Because A, the amplitude, is the radius. And wouldn't it make sense that it's 40 feet? Like look at the distance between 5 and 45, right? So you know that the Ferris wheel has a diameter of 40. So there's a lot of ways to verify what you're doing. How high above the ground is Tom at the lowest and the highest point? I already gave that away. So highest is D plus A. So I'm going to go 25 plus 20, that's 45 feet. Just make sure you have feet. Lowest, it's D minus A. 25 minus 20, that's 5 feet. Explain why this might be the case. Like, why is the lowest 5 feet? And this is just me trying to be smart, but it's not. That doesn't really. I don't think. If you think about it, you wouldn't want to be right at 0, right? Because people's feet, if they just have them dangling, they'd be gone, right? So you always want it a little higher so that the platform can go onto it, and then you go off the Ferris wheels for safety reasons. So how about we just leave that one? Determine the period. What does it represent in this context? The period can be found by going 2 pi over b. And I know I'm doing this again, but I kind of want you to know that this I kind of do on the side anyways. Like to find my graph, I do this anyways, but sometimes the province will specifically ask you for it, okay? B is 1.57075, so we'll just say that it's 4 minutes exactly. What does it mean? So you have to explain. It takes 4 minutes for the wheel to complete a full revolution. That's for a wheel. If it's, for example, the ocean tide, so let's say the tide is like 12 hours, it's about 12 hours, right? For a high tide to come back to a high tide, just say it takes 12 hours for the high tide to go down to its lowest and back to the highest. That's the best way to describe a tide, right? So try to use the context as best as you can. Determine the y-intercept. What does it represent in this context? Okay, so let's figure out the y-intercept. How do we do that again? Second, trace value, x is equal to 0. And we get that y is 6.02, and we are in feet. Why is it not 5 feet? Let's get rid of the why is it not 5 feet. What does it represent in this context? It is the initial height of the ride. A single seat, that is, right? So if you focus, oh, you can't see that, my bad, sorry guys. It is the initial height of the ride. So if you focus in on a single seat, right, that would be the starting point for us, 6 feet. And so for a tire, sometimes they say that, hey, imagine a rock gets stuck on the tire, and now we keep track of that rock, right? Same thing. So graph this for 2 revolutions. Let's do that. I'm going to start with the basics here. Time in minutes, height in feet. Remember, along the y, we're interested in the low, the mid, and the high. So let's see here. If I make this 5, 10, 15, 20, that's not going to work at all. If I make this 10, 20, 30, 40, that will work. So I'll make this 10, 20, 30, 40, 50. And the question is always, I think the Y we get. Most students are like, yeah, I get the Y, the low, mid, high, got it. What about the X though? What did we do on our X max on our calculator? We put in 12, right? Let's go to our window. I went 3 times the period, so that got me to 12, right? I look at my graph. This is one cycle and another cycle. So that will give me 2 full cycles if I get all the way to 12. So that's what I'm going to do. I'm going to make this 5, 10, then it's too compressed. So I'm going to spread it out. I will go 2, 4, 6, 8, 10, and this gets me to 12. Oh, wait, the 12 is off, right? I'm missing, I sliced this grid a little bit too early. There's 4 boxes. There should be, 12 should be right about there. So be careful with that. The province won't do that to you. They'll make it work. But if you need to rescale, then do it, okay? And now, I need to figure out my max, right? I look at my calculator. This min here is in the negatives, right? So I'm going to focus on this one here. I'm going to find that max. Let's go ahead and find it. Second trace max. Boom. Boom. There we go. That's 1.8. Right? 1.795. That's 1.845. So I'm going to put this down first. Max that I found, 1.845. And the first low, I need to know the exact location. I know it's going to be 5, right? In terms of the Y. So you got to go min, travel to that one, enter, enter. You get 3.845. Got it? Let's plot this. So 1.8, this would be 1. Let's see here. This is 1. 1.8 is somewhere here. So I go 1.845. Because 45 is between 40 and 50, right? So here. And then 3.845 would put me right about here. Why did I say 45? That's 5, right? My bad. Please change this to 5. So 3.85 is right about there. And what do I do now? I use the period to help me find the other ones, right? So if I add 4 to 1.8, where do I land? 5.8, right? And if you have to use your calculator because your period is like a decimal or something, just make sure you do that. So I'll add 4. That gets me to 5.8, right about there. And then I go to this low one here, and I'll add a period to that one. So 3.8 plus 4 is 7.8. And how about we start already to see what this looks like. So you wouldn't quite get the full marks here because you don't show 2 full cycles. So I'm going to take this. I'm going to make a mark for me here. This is 7.8. No, sorry, 5.8. 5.845 to help me out. This is 1.845. So I'm going to add another 4 here. That gets me to 9.8. And then you just go to that one. And at that point, you're good to go. Just go arrowhead. Just go a little past it. Make it face down. You're good. Go a little past it. Make it face down. You're good. But we know what our x-intercept, our y-intercept is, right? We do know what our y-intercept is. So how about I'm going to include that. This is 5, so this would be 2, 4, 6. It's right about there. So actually we can, it's not that much work because we already know where it is. And I'm going to get rid of that arrowhead there. Just make sure you don't go into the negatives. If you go past that y-intercept into the negatives, you're going to lose a full mark because you're going against the domain and range of this question. Okay. Graphing is not too bad, guys, if you just know, right? Make sure you find that one, and you just add a period, right? Then go find this low one here, which was 3.85. You do not need to label them. That is just for you, for your notes. You do not need to label these ones. As long as they are on the graph where they're supposed to be, you're good to go. Okay. And I'm missing one thing. I'd lose half a mark right now. The equation. Oh, that's not, it's h, right? h 20 sine. Even if it's like a doctor's note style label, you get the marks, okay? So it doesn't have to be pretty. Just make sure it's there. Usually if the province asks you to graph, they'll ask you to graph and then maybe one more question, that's it. Like there's not like A, B, C, D, E, F, G, right? Like that's a little intense. All right, let's keep going. Good. How long does Tom stay at or above 30 feet during one revolution? Okay. So remember, it goes like this. It goes like this. And then, right? So let me tell you this. It doesn't matter where you find out. You need to just make sure you draw your 30 line. This is your y2 is equal to 30. And you're going to find out this point right here. That's what I call time 1. And this point right here, which is what I call time 2. And then we're going to do a delta t, where we go time 2 minus time 1. That is going to give us the time spent at or above 30. Okay? So I'm going to figure out time 1, I'm going to figure out time 2, and then subtract it. Oh, I should say this. Somewhere in here, I'm going to show my work. Second trace intersect. If the province says show work, make sure you do that, okay? I let y2 equal 30. And so it doesn't matter which wave you pick, guys. It doesn't matter. If you were to subtract those two, you're going to get the same answer every time. I will pick the first wave right here. Second trace 5. I will go all the way to the left there. Enter, enter, enter. And write down 4 decimal places. 0.9567. There we go. That's the number you were looking for. Another one. Second trace 5. And that one is 2.63 499. So it actually turns to be that. And you get, I need to redo this one, delta t, I'm just going to subtract them, 2.635 minus 0.9567. That's 1.68 minutes. Above. Question. Province always likes to be, bless you. What if I asked you how much time was spent below? Right now with what you know. What's the total length of the ride? 4 minutes, right? Is it 5? Sorry. Is our graph wrong then? Because our period is 4, isn't it? The y-intercept wasn't the same? Everybody had different? Or did we all get a different number for the y-intercept? No, the only thing I'm saying is my mistake was, and maybe we'll talk about that. My mistake that I'm realizing now is that the period is 4 minutes, and I think I kept on adding 5 minutes, right? Or did I? No, we're good. Okay, phew. I thought I added 5 every time. We're good. We're back in business. I just want to let you know, time below, if they ever do that to you, time below, I will just go total minus time above. That is the way to go when it's asking you for time below. So I'll go 4 minutes is the length of an entire cycle, right? That's a full ride is 4 minutes. You take away 1.68, and that gives you 2.32 minutes. This is just an aside. That is not what this question is asking. But I'm trying to prepare you for all scenarios. What's the domain and range? The domain is tricky because I don't know if you read. Let's go back to the question. What does it say at the very end? That this ride goes on for 5 revolutions. 5 revolutions. Domain, 5 revolutions times 4 minutes. That would be a total of 20 minutes of runtime, right? That's when the ride kind of ends. Okay? So for the domain, I go from time 0 to 20 minutes. Oops, I shouldn't put minutes in there, sorry. When it comes to the range, that one I would expect you to know, right? We go as low as 5 and as high as 45. Okay. Keep going. This is to see if you understand what the equation, what changing A, B, C, or D does. Write an equation that would give you a Ferris wheel with that is higher off the ground. What would you change to make the Ferris wheel go up altogether? A, B, C, or D? Remember what this one does? This one brings everything higher or lower, right? Changing this one. So if you increase D, that's what's going to happen. If you decrease D, the whole thing is going to come down. Okay? So one way to do that is to change D. So I will say increase the value of D. It doesn't matter by how much. So I'm going to copy paste the exact same thing. I will just go plus, how about we go 35? Boom, you're done. A Ferris wheel that takes less time to complete a full revolution. Which one messes with our period? Like which variable? A, B, C, or D? B, right? B is the one. And I will say this, increasing B, right? If you go B up, you have a shorter period. If you decrease, you have a longer period. And I think you need a visual here. Shorter period would be like this. A longer period, you would stretch this out. It would be like this. It would take longer to complete a full cycle. Okay. So if you want less time for it to complete a full revolution, we're going to increase B. How about we just go 5t minus 1.25 plus, I'm going to stick with the original value of D in this case, and I'm just going to underline what I've changed. And if you're not sure, type this into your calculator into Y2 and compare it to what you already have. And you'll see that it's like you're going to do a lot more revolutions with this B value. A Ferris wheel that would go 5 feet underground. How would you do that? So if this is our median, which is 25, we reach a high of 45, we reach a low of 5, right? And what's the difference always between these here? That's given to us by the value of A. So what would we have to change so that we go 5 feet underground? A, change A by how much? We would have to go 30, right? Because if we increase this to 30, then it's going to go 25 minus 30, that you go -5 underground. So you go, and then you'd go what up? You would go 55 to -5, 55 to -5. So if I increase this to 30, then I end up at -5. And up here at 55. So this one is a little trickier to wrap your head around, but I will increase A to, let's say, well, we have to be specific here. A is equal to 30. I'll just leave it at that. I'm not going to write out the equation, so that's it's too time consuming right now. And I'm going to close with this one. how many times will Tom have reached the highest point in the first 5 minutes of the ride? There's a couple of things you can do here. Option 1, go second trace value, x is equal to 5, then count. That's what I would, that's probably one of the easiest way to do it. But if the ride is 4 minutes, right, then you can only have reached the highest point once, right? Within the 5 minute, 4 minutes, and the ride, after 5 minutes, you will only have reached it once. But let's say you don't. So let's say we go x equal to 5. You're right here. So you count from the beginning till there. You only reach the highest point once. Okay? But what if the question said after 20 minutes? Can't even see that, so I need to increase my window to let's say 25. And then I'm going to try this again. Second trace 120. This is where you're going to be at 20 minutes, right? So you count. How many times will he have reached the highest point? 1, 2, 3, 4, 5 times, right? So that's in my opinion, the best way to do it. One time. Option 2, go time divided by cycle. Period. I'll just go period. So 5 minutes divided by 4 minutes, that's 1.2. So it's approximately 1 time. So you can't round up on this in this case, right? You didn't quite make it another time. So whichever one works for you. Okay. I'm going to stop here. I'm going to ask you to, I'll come back to this page if you're still copying. I'm just going to check real quick. I want you to try, let me just look at my key ones here. Question, page 23 and page 24, because 24 goes underground, like it goes below the x-axis. So 23 and 24, I ask you to graph both of them. Unfortunately, I don't provide a grid, so you're going to have to make your own using a ruler. But make sure you know how to do that. So I'll do that. Don't put your stuff away yet, please. There's one more thing that I want to talk about. We're going to go to page 21. And some of you will be able to do, another question on the exams that I gave you. Sinusoidal regressions. This is on page 21. This is the easiest one, okay? I give you the points, you just have to type them in. So let's do that real quick here. Mr. Dixon is going off-roading with his Jeep. He gets to a point on the road where there's a 1 foot of water standing, right? And so he records a certain point on the tire with respect to the water, and this is what I get. So there's the time, and there's the I guess the point of the tire with respect to the water. So at some point, that point on the tire is underwater, and at some points it's above water, right? You see that? And so let's type that in. Remember, you type the top row into L1, the bottom row into L2, just like before. Nothing changes. Let's go and do that real quick. I won't assign homework on this yet because I haven't done a full one. You have that in. Then we go stat, calc. What are you going to pick? Sinusoidal regression. That's the last regression that we're going to do in this course. It's way at the bottom. Sine reg, there you find it. Hopefully you see it, right? Sine reg. And then you do the same as before. Second 1, comma, second 2, comma, alpha, trace, put it into y1, hit enter, and there's your formula, your equation. Round to 2 decimals, but leave everything on the calculator, of course, right? Why do I do more than 2 for B? Because it gives me a more accurate period when I calculate it, that's all. Mr. Dirksen, will I get deductions if I round it to 2 decimals? You will not get deductions if you round this to 2 decimals. Okay, you'll be fine. I'll leave it there. That's all I wanted. I wanted you to do a regression to know how to do it. Just do 23 and 24.